Migrating from a light prop to a high complex jet is not easy. The flying itself it's basically the same. Pull the yoke and the nose go up. Push it and the nose will go down. But understanding the aircraft systems and subsystems and moreover how to interact with them, it's the giant leap every pilot has to face. And the most complex one is usually the electrical system. Buses, inverters, rectifiers, and a whole lot more that make some pilots have nightmares trying to understand them. So this is a video focused on turning this complex matter into a very simple one. Welcome to a masterclass of electrical systems for complex aircraft. Hello folks, welcome to the Aircraft Performance channel. My name is Thiago Brenner and today we're going to talk about the complexity of an electrical system, but I promise to make it as simpler as it gets. In this video I will use a Boeing 737 electrical system as an example, and we will build from that. First of all, what are generators? Well, this is a unit connected to the engines or APU that is able to generate electrical power. But we can think of it as a power outlet in our house. And yes, this 3 round holes is the standard power outlet in Brazil. Anyway, next step. Pilots say we need to connect the generator to the transfer bus. What the heck is a transfer bus? Calm down. No, a transfer bus is not this. We can think of a bus as a big power outlet hub, like the ones you use when you need to connect several equipment but only have one slot on the wall. Now, how many generators this airplane has? Well, the Boeing 737, our model on this example, has 3 generators, hence the 3 outlets on the wall. What do you mean 3? I can clearly see 4. Well, think of each rectangle as a single generator. This is the engine number 1 generator, this is the generator of the engine number 2, and this is the generator of the APU. The APU generator is the only generator with 2 separate slots to connect to your outlet hub, but is still a single generator. The problem now is that only one hub is not enough. We need way more slots to fit all the equipment within this airplane. What do we do then? Get more outlet hubs and connect one to another, of course. But don't worry, this probably would set your house on fire. The airplane, however, is designed to handle that. Now, it is important to spread our devices along the hubs by a matter of importance, grouping together what needs to be grouped. And we will name each hub according to its importance, always using the name bus to refer to that hub. So the first hub that is connected directly to the power outlet on the wall, that is the generator itself, will be called the transfer bus. And we have 2 of those, the transfer bus 1 and the transfer bus 2. At which power outlet on the wall are we going to connect each one of these 2 transfer buses? See, I will paint one slot yellow and the other one green, and I will do the same with the transfer bus. So the green transfer bus can only be connected to the green slot, and the same is true for the yellow one. You have probably realized already that the transfer bus can only be connected to the generator 1 or the APU. The transfer bus 2 can only be connected to the generator 2 or the APU as well. But there is no way of connecting the transfer bus 2, yellow, to the generator 1, green. Or is there? Well, each transfer bus has a separate slot reserved to be connected by the other transfer bus in case it needs. Let's give an example. I will connect the transfer bus 1 to the generator 1. Suppose that generator 1 is the only working generator at this moment. How will the rest of the airplane be fed? Simple. The transfer bus 2 will be connected to the transfer bus 1 and get the required energy from that to feed the equipment connected to itself and to share this electricity with the other buses connected to it as well. Okay, but this kind of connection between transfer buses, though possible, are not always desirable. Sometimes it is better to keep both sides isolated from each other to save at least one side from a short circuit that is happening on the opposite side. On the Boeing 737, there is a switch on the overhead panel called the bus transfer switch. That switch, whenever in auto, allows this transfer of energy between buses to occur. Position the switch to off, and now this connection is cut. You can think of it as blocking the outlet with those child-proof devices that people use on outlets whenever there is a new toddler starting to crawl around the house. Let's use this moment to comment on the main law of every modern aircraft electrical system. There is no parallelism between AC power sources. And what does that statement mean? It means you cannot connect your bus to two power sources at once. It's like trying to pick one plug and connect to two power outlets on your wall at once. It is impossible. You have to pick one. Either an engine generator, an APU generator, or stealing from the opposite bus. But never two options at the same time. Time to re-energize the right side of the airplane. Let's connect the transfer bus number 2 to the generator number 2 that is back alive. Now, even with the bus transfer switch in off, all the airplane has AC power again. And let's name the other AC buses that group some equipment. Let's call them ground service bus 1 and 2, main bus 1 and 2, AC standby bus, and be aware that the real airplane has more buses, such as the galley bus. But anyway, I'm gonna stop here. What all of them have in common? They are all AC powered. But there are some systems on the airplane that require the use of DC power. What can we do about it? I bet you have a phone charger in your house, maybe you're using it right now. So that charger is technically a transformer rectifier. It transforms alternate current that is coming out of the outlet right now into direct current that your phone battery needs to be recharged. On the 737, we have 3 transformer rectifiers, or simply TRs. One is connected to the transfer bus 1 and the other 2 are connected to the transfer bus 2. And what is connected to this TR? We now can imagine another kind of hub, a USB hub. In fact, 6 USB hubs that will also be named buses. But now they are DC buses. We have the DC bus 1 and 2, DC standby bus, battery bus, switched hot battery bus, and hot battery bus. You probably noticed that I have connected only 4 of them to the TRs. What about the other 2? Their names are likely giving up the surprise here, but yes, they are connected to the battery. Now, a big problem here. If I connect those 2 buses to the battery will be depleted at a given time. I must be able to recharge that battery. That is done by a battery charger. That is, in fact, another TR, with this exclusive function assigned to it, and it is connected to the ground service bus 2 in this case. So, how are we making this connection between the battery and the buses that are connected to the battery? Well, the battery has its own USB hubs, and it has 5 slots. 2 will be used to connect and energize the previous mentioned buses. But what about the other 3 slots? They are all reserved to be used in case of the energy supply malfunction of the generators. You see, I think that the beauty of an electrical system is designing it in a way that it is able to keep feeding energy to the essential equipment no matter what. And this system is doing just that. All the essential equipment of the Boeing 737 is connected to 5 different buses. The 5 buses are all of those that have the name battery or standby on it. That is, the switch hot battery bus, the hot battery bus, the battery bus, the DC standby bus, and finally the AC standby bus. At this very moment they are all energized and their main source of power is the generator 1 and generator 2. Even those connected to the battery are indirectly being fed by the generator via battery charger. Now, let's imagine a total generator fail, both sides. Battery will now be the only source of electrical power, and that USB hub still have 3 slots that are there to feed the remaining 3 buses previously mentioned. DC standby bus and battery bus are buses using DC power already and can be connected directly to the USB hub. But the AC standby bus is of course AC. To make it work, we now need to use a device that will do the opposite job of a transformer rectifier. This is the job for an inverter. It takes DC power and changes it into AC power. Different problem now. As the only source of electrical power is the battery at this moment, that battery will start being depleted. How long does that battery take to be completely empty? Well, it is certified to last 30 minutes. But what if we need an extra time? Well, we can always attach a second battery to the system and extend that 30 minutes into a full hour. And what if this 1 hour is not enough? Is there something else? Well, not on the 737, but a lot of other airplane models are equipped with a windmill generator for emergencies called the RECT, Ram Air Turbine. There you go, we have just finished assembling a very complex electrical system. Seeing that way, it doesn't seem so out of this world, does it? If that explanation made it easier for you to understand an electrical system, please leave a like and subscribe to the channel. Share this content with more people with a simple hype. That helps me a lot in creating content for you. Remember to follow me on social media. Thanks a lot, and I'll see you next time.